Now, what's going on? Okay, let me put down my where is our endpoint? So I guess I'm going to make, we'll call this 0. We're moving across here. Okay, right. Now, looks to me by my numbers, I guess we'll set our scale over here as like 60, so that makes, can't do distances. Okay, let's call this 30 or something.
That's pretty close.
Is that about right? I don't know. So that makes 10, 20. Okay, least consistent scale ever. It'll have to do. All right, now what's happening? Okay, let's actually do this. I don't know if I'm going to draw trains in your book, but they both start at time 0 at the origin. Okay, after 1 second, good old Henry, he plods forward 5 meters. Okay, so here we go. 1 second. Okay, after the same second has elapsed, Thomas is way in front, right? 13.9, so that's like, I don't know, that's 15, right? So it's 13.8, something like that. Okay? Say. These things are actually really heavy because they're made out of metal, but anyway. So, okay, now this matches up with what we looked at before, right? Which was that Thomas starts out much quicker, and by a lot, right? That's why he shoots off, okay? What happens as things progress? Well, good on Henry, plods forward, another 5, so there he is at 10. Okay. Now, after the next fight, we get up to 22. Okay, now, hold on, stuck in the wheels. Now, after 2 seconds, right, it looks like Thomas kind of has this in the bag, right? He has this incredible lead. But as things progress, what's going to happen? Another second passes, we're up to t equals 3 now, and now Thomas hasn't even moved past 30, right? And you can see the rest of the numbers. He's slowing down pretty bad. I don't know, just too much gold or something. 32.2 is not nearly as far ahead as it was before. You can literally see the gap closing, right? If we fast forward a bit, let's go all the way up to, say, here. T equals, actually, let's go to t equals 9, okay? 46 and 45. That's 45. 46 I guess would be here. Okay. So at this point, they are neck and neck, right? Can you hear the music to it? Yeah, I know. I watch a lot of Thomas these days. My son is like 2.5,
Sure.
and he's like, "Go Thomas!" Anyway. Now what's happening? What's happening? The distance between them is closing, obviously, and you can see it's the next second, because obviously Henry's just going to keep on chugging at his 5 meters per second. The next second is the crucial one that we're interested in, okay? But before we do that, to actually answer the question, can you now see the relevance of this equation, alright? So in fact, that's what I'd like you to put as your fourth note. I'd like you to write down here, okay? What's useful here in solving this question is this difference, right? Thomas's displacement minus Henry's. Now I suppose a difference, if I flip it around, it's still going to be a difference. The magnitude of it is still going to be the same. Why would I put Thomas's value first and then subtract Henry's? Why would I do it that way? Yeah, because Thomas started out in front, right? So Thomas minus Henry makes sense for most of this, right? So let's actually get some values here, right? You get 0, 8.9, 12, 20, 12 point, I can do numbers, 12.7, 12 point, the numbers keep changing, it's hard to do. This is, oh no, what's 12.2, what's happening here, 10.8, 8.9, 6.6, 3.9, 1.1. Okay, now, there's my values so far, right? They were nice and easy to do because they were just multiples of 5. Now what happens as we transition from t equals 9 to t equals 10, right? Well, it's going to be 48 minus 50, right? So now you get minus 2. And then you'll get minus 5.3. Yes? So what's going on? We were trying to... Oh, something.
Oh, God.
That's what you get for going so fast. Anyway, we were trying to solve this equation. right? But it resists nice, neat, like exact solutions. That's why you have to use your calculator and just mechanically bash out the numbers. Okay. But what you actually see happening, right? And when you do, oh right, go on, sorry. When you do this, right, you can see the significance of a negative number, okay? Because you can pop this into your calculator and you can get the numbers, but you don't necessarily know what it means at t equals 10 when Henry gets up to 50. Stay. Okay. And Thomas is behind him now for the first full scroll. He's coming. Okay. Now, therefore, okay, when you're actually going about solving this, you have to see what's going on, right? Maybe you graph it, maybe you don't, right? By the way, can you see, we ought to have expected this kind of behavior because Thomas's displacement is governed by a log function, right? Which is a thing that slows down, right? It slows down. So this is actually like a decay situation, right? So what's the actual question say? It says, find during which second the trains are level. And then we'll move on to the speed, okay? Now you have to be careful because that language of during which second is kind of different to this, right? During which second is it's an average thing, whereas this is a precise, instantaneous thing, right? So what does t equals 1? What does that mean? It means at the end of the first second, right? So this spot in between here, right? Or maybe I should put sort of like that. Okay. That's the first second. So that makes this the second second, and the third one, and the fourth, and so on. So where does the transition happen? It happens in here, right? In that second, okay? Which is between 9 and 10. So that means it's the 10th second. So there's your answer. How are you going to answer the second part? Find the speed at which the trains are drawing apart at the end of this second. So, not to get into relativity or anything like that, all we're going to look at is the difference in their velocities. Okay? So take t equals 10, that's at the end of this second. Right? Take t equals 10, and you're going to be substituting into the two velocity functions. Right? So I guess you're going to get 20 on 11, right? And this is still 5 because it's independent of time, right? So if you want the speed at which they're drawing apart, what are you going to calculate? Which one's bigger? 5 is bigger, right? Henry just keep. That's why Thomas lost, right? So you're going to go 5 minus 20 on 11, which I think from memory is 3 and 2 elevenths, okay, meters per second. Since it's a speed, you don't say it's negative, right? It's just a scalar. It's just a quantity, a value. All right, now last question: when is Henry furthest behind Thomas, and by how much? And now you can see it actually was kind of valuable for us to put out this table because you can see Thomas starts out and he gets a lead, but then because he slows down, that lead diminishes, right? So which second is Thomas most in the lead during? And the answer is, better than saying t equals 3, is during the third second, okay? Because it's somewhere in here. You don't actually know between 12.0 and 12.7. There could be a max, right? There could be an actual station. I assume there is a station, right? Is it at 3? Is that 3? No, there you go. So, they ask, when is Henry first? So I'm going to say third second, right? And by how much to the nearest meter? Well, since we calculated it to one decimal place, I guess we would say 13 meters.